The last thing I want to talk about is something called bicyclic rings. So you've often seen simple rings like this, but what happens if you have two rings connected? And there are three ways that rings can be connected to each other. You can have them connecting at a single carbon. You can have them connected on two adjacent carbons. And the really strange ones are the ones that connect, and it's kind of hard to see in 3 dimensions, but they connect at two non-adjacent carbon atoms. So another way to draw this structure would be like this. And you remember solid wedges and dashed line in your general chem. So here they sort of identify or connect at two different carbons, these two rings connecting. So all three of these bicyclic rings have a specific way of naming themselves, and two of them name themselves in the same way, and the third one, as you might imagine, again, negotiations on the nomenclature committee, is slightly different. So let's talk about these two compounds. The compound on the top is called a fused bicyclic ring, or a fused bicycle, and the one below is just called a bicyclic compound. So it's key for us to identify what is called the bridgehead carbons. These are the atoms where the rings come together. This is a term you need to know. So bridgehead atoms are the ones that will help us in naming the compound. So let's start with a clean slate. Let's start with our fused bicycle. We've identified our bridgeheads. And so now what I want you to do is I want you to count the number of carbons it takes for you to travel from one bridgehead carbon to the next. That means is I'm going to start at this way, and I'm going to go this way. I'm going to go all the way around until I get to the next one. How many carbons do I pass on my way? Well, that number is 4. I could just as easily go in this direction, and again, come all the way around, and I would also count 4 carbons. 1, 2, 3, 4. 1, 2, 3, 4. And then there's a final path, which is in right next door, and I don't pass any carbons on the way, so there are no carbons. So the way you name this is you start with the prefix bicyclo, and you have some brackets, and you put in them the numbers that you just calculated, the pathway between the two bridgehead carbons, and you go in descending order. So this would be 4, and separate them by periods, 4.4.0. And then you add up all the carbons in the compound. In this case, it's 10, so this would be decane. So this would be bicyclo 440 decane. Clear? For your interest, why don't you, on some other time, not now, name that one. Let's do the same procedure with these weird, funky bicyclic compounds that share non-adjacent carbon atoms. So this line in the back shows that the bond is in the back is split by the bond in front. So again, we're going to find the bridgehead carbons. That's where the two rings come together. And we're going to count paths from one bridgehead to the next. So going in this direction is 2, going in this direction is 2, and going in this direction is 1. So we would number this, or say this as a name is bicyclo 2.2.1, and there are 7 carbons in the ring, in the bicycle, and you can figure that out because for fused and bicyclic compounds, there are 2 bridgehead carbons, and then you add up all the numbers in the brackets. So 2 plus 2 plus 1 is 5, plus 2 is 7, so this would be heptane. That's pretty straightforward. Again, for your own amusement and practice, you can name that one for fun. Finally, there are the ones that share a single atom. And as you might imagine, because it's different, it must have been a negotiation. And again, if we're going to show these in true tetrahedral form, we probably should show them like this. Because we only have one connection, there's only one, if you will, bridgehead carbon. And so we, again, are going to do exactly the same thing we did before, only this time we're going to go on a little trip around the two rings. So 1, 2, 3, 4, 5. 1, 2, 3, 4. And this is called a spirocycle. So we would name this spiro. And then, believe it or not, and this is a crazy nomenclature, people, again, go in increasing number order, not decreasing. I know it's weird. It's an exception. You can just imagine the nomenclature committee having an argument, and this is the negotiated settlement. So spirocycles, they have two numbers, and they go in increasing order. Bicycles and fused bicycles, they go in descending order and have three numbers. I hope this was helpful. Have a good afternoon.